the threat landscape, give you an idea for the kind of threats that are out there, the trends that we're seeing around data theft. Then we'll jump into a quick overview of database vulnerabilities. I'll give you an idea of the type of vulnerabilities that exist in your database systems that attackers tend to exploit. Then we'll get into the fun part of the presentation. I'll show you a few different database attacks and exactly the step-by-step process that an attacker would go through in order to get into your systems and either take down systems that are actively running your business or take control over those systems and have the ability to exfiltrate all the data that's there. And finally, I'll wrap up with a discussion of protection measures and give you a simple step-by-step approach on how to go about improving your database security and becoming compliant. The threat environment's been pretty unbelievable in 2011. We've just seen a massive slew of major database breaches, and they really started right at the beginning of the year with a big breach at an email marketing company called Silverpop. They lost about 20 million records. Shortly after that, we saw Epsilon, another email marketing company, get hit to the tune of about 80 million records, massive data breach. And then almost immediately afterwards, we saw the attacks begin on Sony, first on the PlayStation Network, then on Sony Online Entertainment, and since then about 20 additional successful attacks on Sony that have yielded more than 100 million records to attackers. If we look back since really the beginning of data theft for profit, that industry, I won't say it got started around 2004, but we really started tracking that industry around 2004. And since we started tracking, we've been able to count through Verizon Business and their forensic investigation service over 1 billion records that have been stolen. There's an organization called Ponemon Research that looks into the cost of that stolen data. And every year they publish a cost of a data breach study. The cost in 2010 of a stolen record on average was $214. When you look at data breaches that involve some kind of criminal activity, that cost per record skyrockets to over $315. So we're talking about a dramatic amount of cost that's been absorbed by industry because of these data breaches. And of course, because organizations store the vast majority of their sensitive data in databases, a vast majority of this data that's being stolen is being stolen directly out of database systems. So this is all happening because organizations just aren't doing enough to protect themselves. For example, 96% of the data breaches in 2009 and 2010 were avoidable through simple controls. About 9 out of 10 organizations with credit card breaches in 2010 had failed their last PCI, or credit card security audit. In 2010, about half of the attacks, 43% of the successful attacks, required script kiddie skills or less. When I say script kiddie skills, I mean the ability to use Google, the ability to cut and paste and run basic software on your machine. No need to be able to really hack or to write code or know Unix shells or anything like that. 92% of all successful attacks were not considered highly difficult. Not considered highly difficult, we're talking about attacks that maybe you need some system administration skills to run, but where you don't need to be able to understand and write your own code. Finally, 85% of attacks that were executed by insiders were perpetrated by non-technical employees. So a lot of the attack activity that we're seeing isn't being run by elite hackers that really have a ton of skill and are doing very sophisticated things. It's quite the opposite. The vast majority of the hacks we see out there are very simple. The attackers are going after the low-hanging fruit, and that makes a lot of sense. Why bother to execute a sophisticated or advanced attack when you can execute a very simple attack and yield the same results? So let's talk a bit about database vulnerabilities. There's a few different classes of vulnerabilities that exist in databases, and well, it shouldn't be surprising that these are the same classes of vulnerabilities that we deal with in pretty much all our other computing systems. Databases have authentication mechanisms. They have usernames, and those usernames have passwords. So weak passwords is a real issue in databases, as well as default accounts and passwords. most of the database platforms ship with some set of accounts built in by default, and the passwords for those default accounts are well known. Then we've got patchable vulnerabilities. Patchable vulnerabilities fix code-related problems that exist in the database, and we see a lot of database security patches being released from the vendors on a regular basis. And then finally, misconfigurations and excessive privileges. Databases are so complicated, and they have really powerful privilege mechanisms. The thing is, it's very easy to make a mistake with the configuration and the privileging in the database. And to make matters worse, database vendors tend to ship their databases insecure by default. It makes it more convenient to use the database, but it also makes it easy for a hacker to break in. And really, it doesn't matter which vendor you choose as your database supplier, whether it's Oracle, Microsoft, Sybase from SAP, IBM DB2, MySQL from Oracle. All the database platforms out there have this common set of classes of vulnerabilities. Let's get a little more specific. So in terms of weak passwords, databases, they all have user accounts and passwords that folks use to get in. And when we look at defaults, here's a couple of examples. In Oracle, we've got a default account called System. It's a DBA account in the database. It's an administrative level account, default passwords manager. There's also an account in Oracle called SYS. SYS is the root account for Oracle, the most powerful account in the system. Its password is change on install. Now, when you install a new Oracle database, the first thing you have to do is log in as SYS once that database is installed. So you're going to type SYS and then the password change on install. Now, you'd think that folks, when they go through that process and they type that password change on install, the first thing they're going to do is change that password. Unfortunately, I've found so many production environments where I could just walk up to the Oracle console, type the username SYS and the password change on install, and get complete access to production systems. Finally, on the Oracle side, we've got the user DBSNMP. That's the user that Oracle Enterprise Manager uses to manage the database. Enterprise Manager is sort of a central management system for Oracle. The password is DBSNMP, and this is not a very highly privileged account, but it does have access to some important data in the database that an attacker could leverage to become highly privileged. Almost every production Oracle database I see has the account DBSNMP enabled, the account is unlocked, and the password is almost always DBSNMP. And it's not just an Oracle issue. With MySQL, we've got the user root, the most powerful user with a blank password by default, the user admin with the password admin. Sybase and SQL Server each have a user called SA for system administrator with a default password that's blank. Now, over the years, the database vendors have taken steps to try to improve this situation. For example, with SQL Server, when you install a new SQL Server, you actually have to check a box to allow you to use the default password for the SA account. Otherwise, they want you to type in a password. Unfortunately, folks are still checking that box to leave the SA password blank. This is an issue, and we need to worry about it because not all databases have account lockout mechanisms. So while most modern database versions do support a way to lock an account if somebody puts the wrong password in too many times, most of the legacy systems that we've got in our production environments don't have those features. And oftentimes, even the more modern systems that have the features don't have the account lockout features enabled. That lets somebody guess passwords all day long without breaking the database. At the same time, while pretty much all versions of databases have some audit ability where you can track database logins, it's unusual for folks to turn that login auditing on, and even more unusual for folks to look at the logs that are produced by that audit. Finally, scripts and tools for exploiting weak passwords are widely available for free download on the internet. There's literally dozens of different hacker tools that support cracking passwords in various types of databases. Those tools are extremely fast, they're extremely powerful, and as I mentioned, they're widely available for free. Let's move on to missing patches. Databases, they have their own privilege escalation weaknesses. They have their own denial of service conditions and buffer overflows, and these classes of vulnerabilities are typically fixed by applying a patch from the database vendor to the database. So when I say privilege escalation, what I mean is taking a user and being able to increase the level of privilege that that user has in the database potentially to become a DBA, an administrative user, or an equivalent privileged user that has access to the business data in the system. So now the service attacks are a class of attacks that result in the database crashing or failing to respond to queries or connection requests. So basically it takes the database down so it stops working. And finally, buffer overflow attacks. Buffer overflows are often the scariest ones. A buffer overflow can allow an unauthorized user to load their own code into the database and have the database run that code. That gives them full control of the database and the database server, complete ownership of the data that's there. Obviously a very, very powerful class of attack. The worst buffer overflows are exposed without authentication. So there is a class of buffer overflow attack where even without logging into the database or knowing any username and password, somebody's able to take complete control over that database system. Really important to take the patches that the database vendors are putting out there. Finally, misconfigurations. If you don't configure the security features in your database properly, it can really result in a very, very vulnerable system. And as I mentioned, the database vendors tend to ship the database configured for convenience rather than for security by default. Let me give you some examples. In Oracle, by default, you get an external procedure service. What that allows you to do is call DLLs to run functionality at the operating system level from the database. That's very cool if you're building applications in the database to give them enhanced functionality. It's also very cool if you're an attacker who's penetrated a database with SQL injection, for example, and now has full access through the external procedure service to run the functionality at the operating system level. By default, Oracle also grants privileges to grant yourself Java permissions, and we're going to take a look at that one in one of the attacks today. Oracle ships with default web applications. Those default applications are for sample demonstration purposes only, and they tend to be filled with vulnerabilities. And finally, Oracle ships with the privilege for public, that's everybody in the database, to execute a function called the UTL file. The UTL file allows you to read and write operating system files through the database. And by default, everyone in the database has got rights to read and write files on the operating system. It's probably not what you want folks in the database to be doing. In MySQL, there's a user table. That user table stores usernames and password hashes. There are permissions granted on that table by default. If somebody can access your usernames and password hashes, it's trivial for them to get a password cracking tool and determine everybody's real password. Sybase and SQL Server, again, share some common roots, so there's a lot of commonality here. Both have a function called XP Command Shell. XP Command Shell allows you to run operating system commands from the command prompt effectively through the database. If folks have access to that function, effectively have complete control of the operating system. IBM DB2's got a privilege called Create Not Fenced that's often granted by default. Create Not Fenced allows logins to create stored procedures. One of the most common attack mechanisms we see with databases involves somebody creating a stored procedure from code in the database that's designed to grant themselves more privileges. Now these users aren't privileged enough to actually grant themselves privileges, so they create these stored procedures and try to trick other more powerful users into running these stored procedures for them. And you'll see an example of that kind of behavior again today. It'll be an Oracle attack, but it's something really similar. Remember, simple changes can make a big difference. 96% of breaches were avoidable through simple controls, and 85% of breaches were not considered highly difficult. It's these simple configuration issues that are leaving systems exposed to these very simple attacks. So as promised, let's get to the fun part of the presentation. Let's attack some databases. Our first target is going to be an Oracle 11g database. We're going to target Oracle 11g Release 1. And this exploit can be run by anybody with login privileges to the database. In Oracle, the privilege to log into a database is called Create Session. The result of this attack is going to be complete administrative access to the database and ownership of the operating system that the database runs on. And I'm going to do this by exploiting an OS command injection vulnerability in a package called dbms jvm exp for export perms for permissions. So it's jvm export permissions and a function in that package called import jvm permissions. This vulnerability was patched by Oracle in April 2010 with their CPU. Of course, only databases that have been patched by that CPU or a newer CPU are no longer vulnerable to this attack. Let's go ahead and attack Oracle. Now, as I mentioned, the goal of my attack is to take complete control over not only the database, but the operating system that it runs on. And to demonstrate my ability to control the operating system, what I'm going to do is create a new file on the operating system through the database. So let me just start by making sure that the file that I'm going to create doesn't exist. So here I'm on a Linux box, and I'm using the ls command to look for a file in the temp directory called Oracle dbms jvm exp perms poc. And when I run that ls command, the operating system comes back and says, hey, there's no such file or directory sitting in this space. So, okay, I'm getting started here. There's no file. My goal is going to be to create this file. Now, in order to set things up further, I'm actually going to create a new user in the database in order to run the attack. And I'm going to do that just to prove to you that I'm using the absolute minimum set of privileges that I can use. So I'll get started by logging into the database using SQL+. That's Oracle's built-in ad hoc query tool. I'm going to use OS authentication. That's why we see SQL+/. And I'm going to log in as sys, or sysdba. So I'm going to log in as a legitimate root administrator to Oracle. And I'm doing this just to create the new low-privileged user that I'll use for the attack in the next step. So when I log into Oracle, Oracle tells me that it's running 11.1.0.6. That's Oracle 11G Release 1. And I get my SQL prompt where I can then go ahead and create my user. So I'm going to create a new user in the database using the create user statement. The username is user1, and I'm going to give them a password pass. So the syntax here identified by the password. So the password for user1 is going to be PASS. I need to go ahead and grant that user1 the privilege to log into the database. So Oracle's a little unusual here that you not only create a user, but you grant the user the privilege to log in. And that privilege to log in is called create session. So it granted the create session privilege to user1. And now I have the absolute minimum privileged user that I can have in Oracle. They have no privileges other than the right to log into the database. So now let's log into the database with user1. I type connect user1. Oracle prompts me for my password. I type that PASS password, and I'm connected. Now the next thing I'm going to do in the database is take a look at the Java policies that are set up in Oracle. Oracle's got a whole Java virtual machine built into the database. And here I'm asking Oracle to tell me the name of users that are granted the Java policy called all files. And what that basically means is who has the right to access the entire operating system through the Java virtual machine. So select grantee name from user Java policy where name equals all files. And what Oracle comes back with is no rows selected. There are no users in this database that have the all files full operating system access. That's good. That's really what we want to see. The next thing I'm going to do is attempt to run some Java code, or attempt to use the Java code to run some command line, run some commands at the command line in order to really try and create this file that I was talking about earlier. So I'm going to use the package dbmsjava.runjava, and then I'm going to go ahead and I'm going to use the command touch, so you can see /bin/touch, and then the file name that I'm trying to create, /temp/oracle dbms jvm exp perms poc. Now the touch command in Linux, if you touch a file that doesn't exist, the file will be created. So I'm attempting to use the Java subsystem to run the touch commands to create this file. And what happens is Oracle gives me an error. Error at line 1, Java call is terminated, and you can see sort of in the middle of this block that the privilege to run this command has not been granted to user 1. User 1 doesn't have the privileges to run Java commands. That's great. That's what we want to see, right? We don't want the low privilege users in our database systems to have the right by default to run Java commands at the operating system level. Everything so far is good. Now let's go ahead and start running our exploit. So I'm going to create a block of SQL code here. And the first thing in that block of SQL code, I'm going to create something called a policy, a temp Java policy. And then I'm going to create a cursor, and a cursor is a construct within the database, and I'm going to use that cursor to hold some data. And the data that I'm going to hold here is this word grant, the user, sys, Java IO file permissions, all files, and the execute privilege. Basically what I'm doing is putting together a policy map for the Java system that's giving my user account the privilege to access the whole operating system. Now I take that cursor called C1, I push the data from the cursor into the policy, and then the attack is this one line of SQL code where I use this function dbms jvm experms.import jvm perms, and I pass the policy. Effectively what I've done here is I've created this policy for what Java privileges my user should have, and I've run the built-in Oracle function to import that policy map. The problem here is that Oracle is letting me, as a low-privileged user, import Java privileges and effectively grant myself whatever JVM permissions that I want. So as a result of this little block of SQL code, I can now go back and I can run that statement, select grantee name from user Java policy where name equals all files. Tell me those users who have the all file Java access. And now instead of getting no records returned, I see that user 1 has full operating system access. So I've granted myself full access to the operating system. And now when I go back and I try to use that dbms java.runJava function and run that touch command to create that file in the temp directory, I no longer get an error. The command works. And if I go ahead and exit from the database and run that ls command at the operating system level one more time to look for that file /temp/oracle dbms jvm experms poc, the file now exists. At this point, I've now assumed the ability to run any code I want at the operating system level through the Oracle database. I'm running that code as Oracle, so I have complete ownership of all the Oracle files, all the Oracle data, and all the operating system privileges that the Oracle database maintains, which are very significant privileges at the operating system level. I own this database and the server that it runs on. Now, I'll admit, that's kind of a complicated attack. There were a bunch of steps there, and you have to write SQL and talk to the database. But honestly, it's not complicated at all. Go to Google and type dbms jvm experms exploit. Click the first link, and what you'll see in that first link is exactly the code that I just ran against the database. This is a simple cut and paste exercise for somebody to take complete control over databases without any need to understand this exploit, without any need to know how to run SQL or anything like that. It's this easy. I just clicked the first link. So for our first attack example, I was able to take complete administrative control over the operating system and run commands with the Oracle Software Owner account. I did that by exploiting vulnerabilities in the dbms java experms package, and I did it with freely available exploit code. You can just go ahead and Google dbms jvm experms yourself, and you'll find that exploit code. Let's do another one. This time, let's attack IBM DB2. We're going to attack DB2 version 9.1 fixpack number 8. Any user with a login to the database can run this exploit, and this is going to be a denial of service attack. I'm going to crash the database server. However, I'm using a heap overflow in the built-in scalar function repeat to accomplish this denial of service. A very carefully crafted attack with this vulnerability would likely allow an attacker to run arbitrary code on the database server. So this is a big hole. IBM fixed this vulnerability in DB2 9.1 fixpack number 9. So this time I'm running DB2 on Windows. And DB2 leverages the Microsoft Windows or whatever operating system it's running on. It leverages their usernames and passwords for a login to the database. So I'm going to start again by creating that most basic user. But this time I have to create the user at the operating system level. So using Windows, use the net user command to create a new user called user1. I give them the password pass, P-A-S-S. /add means add that new user. And I was able to successfully add a user. So now let's use user 1 to log into the database. So you can see on my screen here my DB2 prompt, connect to sample. Sample is the name of the database. Using the user 1. It asks me for my password. I type in the password, and now I've got access to my DB2 prompt. From here, the attack is very simple. One line of SQL code. I'm going to use the scalar function repeat. So I'm going to make a recursive call to the function repeat. And I'm going to pass the parameters in the inner call 1000, and in the outer call this big number 107374, so on and so forth. From sysibm.sysdummy1. Sysdummy1 is a dummy table that ships with the IBM database, similar to the dual construct in Oracle. But it's this simple. I run this one line of SQL code with this whole bunch of repeat of the character 1. You don't need any special privileges to run the repeat function. The repeat's just built in and anybody can use it. And when I run that, the database crashes. So here's the Windows Service Control Manager, and you can see that the DB2 service is terminated unexpectedly. DB2's crashed. All it took was this one line of code. We overflowed the heap. We ran right into program space, and we were able to kill the database from running. One simple step. Once again, you don't need much special knowledge. Type DB2 repeat overflow into Google. Click the first link, and you'll find exactly the same code that I just ran. Once again, it's a cut and paste exercise. No hacker skills needed, just the will to execute the attack. So this time, we were able to crash the database server. We did it by exploiting a heap overflow and the built-in function repeat. We did it with freely available exploit code. Let's do one more. This time, let's attack the most modern version of Oracle. We'll attack Oracle 11g Release 2. This time, we need a little bit more privilege in the database to execute our attack. I'm using this particular attack because it's a good example of the kind of vulnerabilities we see in Oracle on a regular basis. I've chosen one with a little bit higher level of privilege, well, because I don't want to demonstrate, I don't want to give you too much on how to break into a database, an Oracle database, with no privilege at all. But this is a very good example for how attacks where you can create a procedure or create some code in the database work to allow a low privilege user to escalate themselves to an administrative level user. So I need the function, I need the privilege create procedure, and I need to be able to execute the function called mdsys.resetInprogIndex. In the end, I'm going to become the DBA in the database. I'll have full administrative access. And I'm going to do that by exploiting a privilege escalation vulnerability in this function, mdsys.resetInprogIndex. Oracle patched this vulnerability early this year. Now, this attack is a little bit complicated. There's really 3 steps. So let me walk you through the steps before I walk you through the attack. First step, I'm going to set up my attack by creating a procedure called myproc. And that procedure, myproc, is going to contain some code that's designed to grant my account DBA rights. Then I'm going to create a function called myFN, or myFunction, and that myFunction is going to contain code that creates a trigger in the system schema. So the system schema is a piece of the database that the account system owns. System is a DBA. And a trigger is a piece of database code that automatically runs when certain conditions are met. So I'm going to set things up. Then I'm going to actually exploit the vulnerability. And in order to exploit the vulnerability, I'm going to cause the built-in default account called mdsys to run my function. That's going to create this trigger. Once the trigger gets created in the system schema, I now need to take the last step, and I need to trick the account system into running this trigger for me. When it runs the trigger, it's going to call myproc, and the account system is going to run the code that I've written to grant my account DBA. So first we'll set it up, then we'll run the exploit, then we'll collect our rewards. Now before we get started with any of that, well, let's create our basic account so that, again, you see I'm running with these minimal privileges. So I'm going to log into the database as a DBA. This time we'll use system. Then I create that user account called user1, identified by, this time the password will be admin123. I'm going to grant connect to user1. Connect is very similar to create sessions. That gives the user the ability to log into the database. I'm going to grant user1 the create procedure privilege. And I'm going to grant user1 the ability to execute this one function called mdsys.resetInprogIndex. So that's the set of privileges my attacker is going to have. Okay, so now let's connect to the database as that attacker user. So connect user1 / admin123. That's Oracle syntax for passing the username and the password in one line. We're connected to the database. Now we're going to go ahead and create that procedure myproc. So the syntax here is create or replace procedure, and then the procedure name myproc. Auth ID current user is really important. Oracle allows you to create two kinds of procedures or functions in the database. They allow you to create definer rights procedures, meaning procedures that run as the user that created them, and they allow you to create invoker rights procedures, meaning procedures that run with the privileges of the person who called them. So this is a procedure that runs with the privileges of the user that calls the procedure, current user. This is an invoker rights stored procedure. And then I give it the actual code. This pragma autonomous transaction just helps Oracle to move along. I begin and then execute immediate grant DBA to user1. So that's my attack code. That's the code that's going to grant the DBA role, the administrator role, to my attacker account user1. So I type ends. That 2, 3, 4, 5, 6, 7 is Oracle counting up the lines in my little block of code here. The procedure is created. Now I'm going to grant rights to execute my proc to public, meaning I'm going to allow any user in the database to run my procedure. So I've got this myproc set up. It's got code in it that's going to attempt to grant DBA privileges to my user account. The next step is for me to create this myFN, my function. And again, this is an auth ID current user. This is an invoker rights function. So this function will run with the privileges of the user account that calls it. So this time, we've got this execute immediate, create or replace trigger. So I'm going to create a trigger called system.evilTrigger. The system piece means that's the schema or the user space that it's going to live in. It's going to live in the system user space, and it's going to be called evilTrigger. And the text or the functionality in evilTrigger is going to look like this. The trigger is going to fire before an insert on the table called system.ol$. And it's going to fire once for each row that are inserted into that table, system.ol$. Then, inside the block, that begin block, we're just going to call the procedure user1.myproc. That's the procedure that I just built to grant myself DBA. So the end and whatnot. So what I've now done is I've set up a function that creates a trigger that sits in the system schema that's waiting for an insert on a table called system.ol$, and as soon as it sees an insert, it's going to call the procedure user1.myproc. One more time, I need to grant execute rights. So I'm going to take myFN and I'm going to grant execute rights on myFN to public. So every user in the database has the right to execute myFN. So my setup is done. I've got a procedure sitting there waiting to grant me DBA rights. I've got a function sitting there waiting to create a trigger to call my procedure. So now I need to put it all in place. So the next step is to actually run the exploit. So here I'm going to use the vulnerable function mdsys.resetInprogIndex. And I'm going to use SQL injection here. So into the first parameter of this function, I'm going to inject some SQL. And the SQL I'm going to inject is for user1.myFN. So what's going to happen when I call this mdsys.resetInprogIndex is that Oracle's going to allow the SQL injection to happen. So this code, the call to user1.myFN, that's my function that creates the trigger, is going to run. And it's going to run as mdsys. MDSys is a user in the database that has a special privilege called create any trigger. MDSys can create a trigger in any user's schema or space. So this exploit is going to cause MDSys to run my FN, my function. Remember, my function contains that code to create the evil trigger. So while I get some errors as a result of this, it doesn't matter about the errors. I don't really care about what MDSys reset in prog index is supposed to do. I really just care that my function here gets called, and it does. Now that the function is called and the trigger is created, the only thing I need to do now is to insert a record into that table system.ol$. The trigger is waiting for an insert on system.ol$. Now I picked system.ol$ because that's a table that's built into the database by default, and by default public. Every user in the database has the rights to insert into it. So I'm going to insert some dummy values. It really doesn't matter. All I want to do is cause an insert on that system.ol$ to occur, which is going to cause the evil trigger to run. The evil trigger is going to run as the user system. The evil trigger was created in system's user space. It's going to call my proc. My proc is going to run as system now because it's an invoker rights procedure. It's going to run that code to grant my user1 account DBA, and then I'm going to have a full DBA access to the database. So I do my insert statement, one row is created, my trigger has run, and so now I can come back to the beginning and do things like select star from session roles, tell me what role my current user has. And we can see now my current user has the DBA role along with a whole bunch of other stuff that came with it. So I'm now a DBA in the database. I now have complete control over all the data in this Oracle system. Now that was complicated, right? We used a lot of steps. We used a lot of different SQL techniques. I don't think you're surprised by this slide, though. One more time. Go to Google, type mdsys.reset improg index exploit into the search box, click on the first link, and what you'll see is exactly the same code that I just ran against my database to run the same kind of exploit and get full control over the database system. One more time, it's a cut and paste attack. So once again, I got full control of the database. I assumed the DBA role. I did it by escalating my privileges by injecting SQL into a vulnerable function called mdsys.reset improg index. And one more time, I did it with freely available exploit code. Last attack. This is on a very modern version, the latest version of IBM DB2. That's DB2 version 9.7, and this is FixPack 1. This attack doesn't require a login to the database. It simply requires you to be able to talk over the network to the database server. No username or password required. We're going to execute a denial of service attack against the Tivoli DB2 monitoring agent, which is a part of the database. And this vulnerability was patched by IBM in DB2 9.7 FixPack number 2. So this one's real simple. I'm going to use a little script to execute my attack. The name of my script is ITMA, and it's written in Python. So what's in this script, first is a variable or a string called payload. And that string is filled with 5 bytes, 0, 5, 3, 31, 41. Just created a little string here. We check to make sure that the user passes good parameters when they call this script. The script is expecting the user to pass an IP address and a port. Which database are we going to go attack? The script then opens a socket. It tries to connect to that IP address port combination that came in through the arguments to this function, and then it sends this payload that we just created over to the system that it connected to. So it's real simple. We have this payload, it's these 5 bytes, and we're going to send these 5 bytes over to the IP address and port that DB2 is listening. So it's this simple. I now use Python to call my Python script, itma.py. I pass it the IP address of the DB2 database I want to attack, in this case 192.168.209.141, and the network port that DB2 is listening on, in this case port 6014. Done. It sent those 5 bytes to the database using this script. No login needed, no knowledge of the database needed. Now if we go to the database server and we look at the event log, we see DB2 is terminated unexpectedly. The DB2 monitoring agent crashed, and it took the entire database down with it. I feel like all I did was look at the database funny this time. I sent 5 bytes to the database, and those 5 bytes the database did not like at all. It didn't like them so much that the whole database server crashed. Now imagine that this DB2 database is running your real-time trading application on the stock market floor. Pretty painful when that system goes away, even for a few moments during the day. So once again, I knocked the DB2 9.7 database off the planet for a little while. The database became unavailable. I did that by exploiting a denial of service condition in the Tivoli DB2 monitoring agent, which is a built-in part of DB2. And one more time, I did it with freely available exploit code. This time I didn't take a screenshot of Google, but go ahead and type KUDDB2 remote denial of service into Google and see what kind of results you get. You're going to find the same stuff that I just ran. Maybe you feel the way I do now that you've seen this stuff and you've seen how easy it is to exploit databases by just going on Google and finding the exploit code that's been posted online. It's kind of not that big of a surprise to see the number of major data breaches that we're actually seeing these days when you realize that most organizations aren't acknowledging the kind of vulnerabilities they've got in their databases, aren't patching their databases, and are really exposing themselves to some very simple attacks. So let's talk about what you can do and what you ought to do to protect yourself from the basic attacks that we've been seeing. In order to do a good job securing your data in your databases, you need to take a life cycle approach. And I say that you need to take a life cycle approach because your environment is going to constantly change, both your own network and the systems that are on it, as well as the threat environment and the exploits and vulnerabilities that we know about. So this life cycle approach walks you through a process, a repeating process, where you start out by discovering the inventory of databases on your network, classifying your databases based on the sensitive data that they do or don't store, assessing the databases for vulnerabilities, for misconfigurations, and for access controls, prioritizing the problems that you find, fixing what you can, and then using monitoring as a compensating control for the problems you can't. So we start with a database inventory. You really need to know what databases you have before you can protect them. Most organizations have some way of tracking their database inventory, but they tend to be very manual, and the inventory estimates that folks have tend to be way off. I say 30 to 60% in this deck. I'm being a little bit generous. It's not unusual for me to walk into an organization that's got 10 times more databases than they thought they had on their network. You really need an automated way of going out, crawling through your network and identifying all the databases that are out there. So you can either remove them or protect them. You need to have a database inventory that lists those systems that you've got. Once you've got that inventory and you know where your databases are, you can start to think about what your databases are. Because those systems that store or process sensitive or regulated data are going to need some special attention. You want to actually look through the data in each and every one of your databases and look for items that are sensitive, things like names and addresses, credit card numbers and social security numbers, phone numbers and salary information. You need to be able to pinpoint the location of all your sensitive data if you want to be able to protect it. Now, if you've only got a handful of systems, this is something that you can do manually. If you've got a dozen or 100 or more databases, you're probably going to need some automated software-based approach to crawl through that data and identify where sensitive data is stored. Once we know where our databases are and we understand what type of data is in them and what kind of regulatory requirements are going to be imposed on those systems, you can now start to scan the systems for vulnerabilities and misconfigurations. That's going to help us to keep up to date with the security patches the database vendors are putting out there. It's going to ensure that we've got strong passwords set on all our user accounts. Then we're going to take a look at the configurations and the settings from the databases and audit them to make sure that they're compliant with either corporate policy or with well-known documented industry best practices. Now these vulnerabilities that the database vendors are fixing, it's commonplace and they're scary. Software vendors hate patches. Don't like patches because we don't make any money on patches. We make money by delivering new exciting functionality that you can buy. When a software vendor releases a patch, for security reasons or otherwise, it's because they're taking an issue very seriously, and because they realize that it's so important to them and their customers to apply that patch to protect the systems. If a company like Microsoft or Oracle or IBM is taking time out of their money-generating development in order to go back and write patches to fix software they've already sold, take them seriously. Take those patches and apply them to your system. Now, once we've looked at our vulnerabilities and our misconfigurations, we can start looking at our access controls. The first step there is to identify privileged users. Which users are actually the DBAs, or the administrative quality users in the database, and who has access to sensitive data. You've got to crawl through the Oracle Access Control System, the SQL Server Access Control System, the DB2, whatever database you're running, and you've got to identify who the users are and exactly what their effective privileges are, so that you can start to find users that maybe don't belong there and remove them. Now we've got a list of issues. So we find users that should be removed. We find patches that should be applied. We find passwords that need to be changed. You want to go and fix what you can. And while it's as easy as pie for me to tell you to go fix your databases, I know in the real world it's not so easy to actually fix them. Sometimes your application that you're running on that database doesn't support the latest patch level, and you don't want to mess with it. Sometimes your application requires you to run with insecure settings in order for the application to work. In some cases, you just need to reboot the database in order to apply the patch, but your reboot window doesn't come up for another 6 months. So in all cases, you simply can't snap your fingers and fix your databases. You're going to have a period of time where you're exposed. And so fix what you can and monitor what you can't fix, so that if you are exposed, you know if somebody's trying to exploit one of those known vulnerabilities. You know if somebody's trying to take advantage of one of those insecure configuration settings. You can actually track what your users are doing and who's accessing your data and make sure that all that access is appropriate. So maybe somebody's trying to access passwords from the DBA users here. You want to know that. That's an indication that somebody's going to try to guess passwords. And when we see these kind of events, we want to know who did it. We want to know where they accessed the system from. We want to know what data was returned and how many records were touched. That kind of information needs to come through in your database monitoring system so that you can take immediate action. It's not good enough to review audit logs once a week or once a month. You need to know immediately when somebody's executing or beginning to execute an attack so that you can stop that attack before the real damage is done. The last step in our process here is encryption. And there's actually two kinds of encryption you can implement at the database. The first kind is network-level encryption. What network-level encryption does is encrypts the communication between the database client and the database server as that communication flows across the network. It prevents somebody from attaching a sniffer to your network and simply picking up all the sensitive data that the database is serving up or retrieving. Network-level encryption is really easy to implement. It's a simple configuration option on the database side and on the client side. Minimal performance impact, no impact to your applications. Folks should turn on network-level encryption on their databases. It doesn't solve a ton of problems, but it does prevent that network sniffing kind of attack. The other kind of encryption is column-level encryption, and that's when you go inside the database and actually start to encrypt some of the data that lives in the database. Column-level encryption is appropriate and effective in keeping a database administrator out of the data that they shouldn't see in the database. Most users, we just revoke their privileges or deny them privileges to see the data that they don't want to see or we don't want them to see. But we can't take a DBA's privileges to view data away from them. So instead, we can encrypt that data in the database so that if the DBA does attempt to view that data, what they'll see is encrypted data. Now, if that's the issue you're trying to solve, keeping your DBAs out of your sensitive data, column-level encryption can really help. However, it's important that you don't make the DBAs the people that are administering the encryption system. And I see that happen all too often, where the DBAs are the ones who are trying to protect against accessing the data, but the DBAs are the folks that we give the keys to unlock the data to. And effectively, that's just added a burden to the database by adding this encryption without giving you any security benefit. The column-level encryption is kind of a last line of defense. It meets a very narrow use case. It can be very effective to deal with that use case, but you've got to configure it and deploy it properly. For most applications, I don't recommend column level encryption. It just tends to be unnecessary. So let's review. The first step in our program here is to inventory your databases and understand which database systems are running on your network. Step 2, locate your sensitive data. Step 3, scan for vulnerabilities and misconfigurations. Step 4, check your access controls. Step 5, prioritize the issues you find and fix what you can. Step 6, monitor your database activity for exploits of known vulnerabilities, for unusual or suspicious behavior, for attempts to exfiltrate sensitive data. And finally, use encryption selectively where it makes sense. 7 steps, significant database security. So let me wrap up. Just a few links to some resources and references. We will make this presentation available to you. Really, the best place I can tell you to come is our teamshatter.com website. On teamshatter.com, it's sort of your homepage for all things database security. We're going to give you all the latest trends, information about exploits and threats that are out there. I promise that AppSec Inc. is not going to try to sell you software on teamshatter.com. We've got a website, appsecinc.com, where we will try to sell you software. TeamShatter is purely an information resource. It's a great one. There's a bunch of other links here you can take advantage of. I even wrote a book on Oracle security. If you're interested in that, it's called Practical Oracle Security, and it's out there. And that really wraps up my presentation. So I'm going to hand it back to Jeff, and we'll open the floor for the 2 or 3 minutes that we've got left to take a few questions.
Excellent. Thank you very much, Josh, for that presentation. So we have a couple of questions. I know we're short on time, so I'll get started with a popular one, and that is, will this presentation be available? And that question is answered by yes, it will be available within about 24 to 48 hours. If it's not, well, let's say it's 2 business days. If not tomorrow, on Monday, an email will go to anyone who's registered or attended with a link back to the on-demand version of this webinar. So it's great if you want to go ahead and get a recap on the presentation that Josh gave, or if you want to pass it along to colleagues. This other question comes from Sam, and the question is, I work at a small company. How do I convince my company to take the security issues seriously, other than pointing out recent problems such as Sony as an example?
Gee, you know, that's an issue that we wrestle with all the time. I can't tell you how many security professionals I talk to who tell me they recognize they have a security problem, but don't know how to convince their management to take it seriously. Well, I wish it was an easy question to answer, but it's not. What I've found to be very effective is to provide a demonstration of how vulnerable you really are. And to do that, I recommend you bring in a security professional, whether that's an individual pen tester or consultant, or you bring in one of the database security software vendors to come in and actually demonstrate on your systems what kind of vulnerabilities and misconfigurations that you've got and what an attacker can do with those systems. And if you couple that together with the attack activity that we've seen out there, the Sony attack, the attack on RSA, the dozens of anonymous attacks where they've used SQL injection to pull data out of databases left and right, you start to build a pretty compelling case that you need to take it seriously. The attackers are out there. They're obviously well-funded and successful. If the vulnerabilities exist in your systems, it's really a matter of time before somebody stumbles across them and exploits them. You know, it's really luck keeping you from getting attacked. So that's the approach that I would take. I've seen that be very successful, but I can definitely sympathize with the issue that you're running into there.
Excellent. I have one last question, and the question looks like it's about App Detective Pro in terms of finding, using policies within App Detective Pro, Josh, and it's basically the question, to paraphrase, is you know, you've shown a bunch of exploits using exploit code. Is there a way to bring that, to show that a little bit more within App Detective Pro besides just the policy check?
Yeah, that's something that software security vendors struggle with all the time, as to whether or not we want to include actual exploits in our software that allow you to prove it when somebody tells you that vulnerability doesn't really exist. You know, it's been something we've given a lot of thought to, and a lot of organizations have told us that they're unable to run software that allows exploits, actual live exploits to be run. So we've chosen not to include them in our product, at least not the ability to run live exploits. As often as possible, we will give you, in our knowledge base, some information about how the exploits actually run so that you could maybe bring up a query tool and run it yourself. But I encourage you, if you're using our software and you actually want to demonstrate an exploit like this, to give a call to your sales rep or to our support team. They'll connect you with one of our security experts, and we can help you to do those demonstrations sort of on a one-off basis.
Great. Okay, well, that looks like all we have time for today. We appreciate everybody taking the hour out of your day to spend, and we hope everyone has found this webinar very useful. So thank you very much, and expect to receive a link with a copy of the webinar, on-demand webinar, within the next day or two. So thanks again, and have a great rest of the day.
Thanks, folks.